Greetings, I am Dr. N.K. Sakthivel, Principal, Sri Shakthi Institute of Engineering and Technology, Autonomous. So I am handling a course on programming in C and data structure, and the code is 21CES201. In this video, I would like to demonstrate linked list implementation and a simply linked list. As far as this linked list is concerned, this list is the fundamental data structure and which is used for storing the data in the sequence manner and we can access. Unlike array, linked list do not require continuous memory allocation. Continuous memory allocation no need be created or no need be reserved. That is the strength of one of the strengths of linked list implementation. So as far as linked list implementations are concerned, it has a few popular operations like we can insert the data, delete the data, and any data we can search through these different operations. For this purpose, linked list is considered as the best model. And there are the logical relations between each node. For example, see here, we consider A is the one node and B is another node, C and D, and so on and so forth. And A node, has the link to B node through that is address. So that is next is the address pointer. Through that, A has the link to B. Similarly, B has the link to C. Whenever we consider the first node is considered as the head node, and that is the last node, that is node link. After D, there is no more what is called elements and all, data and all. So that's the reason why, this pointer becomes null. So this is the basic concept. There is a logical relations. So after A, link will go to B. From B, link will go to C. That is for additional input I have given. So that is each node consists of data and the next address pointer. Consists of data, next pointer. So like this, each node has the data as well as the next link, that is called the next pointer, that is the next address. Next address means address of this node is stored here. Address of this node is here. So that, once completed from this, the system knows where that is the next node. Where is the next node like this? That I am calling as logical relationship between each node. So with this, I have already told you, that is in this node, there is a data field and the reference that is called address pointer, so that it make a link to next node. So that is a basic concept of this linked list. And as you know, that is first node is the head node and the last node, no more extra nodes, so that the next address pointer is the null. So this basic ideas. With this, I would like to give that is a classifications of linked list implementation. So that is we consider as the three model. Simply linked list is the first one. So each node, points to the next node as this example. This is called one-way traversal. Traversal means continuous what is called walking from first element to all the elements. Is a travel, continuous travel. That's called traversal. As far as the next model, doubly linked list is concerned, each node points to both the previous as well as next node. For example, so here one more pointer is there. So forward walk also possible, reverse also possible. So that is a double side. So that is from first to last. First node is the head and the last. And reverse, this last is the head like this. Forward as well as reverse walk is possible. Two-way traversal, it is called doubly linked list. And the other one is circling linked list. So that is a circle. So, and for example, this connections, instead of null, this D is linked to A. That means D, this address holds the address of A, so that after D, that is link will come to, after D, link will come to A. So that is called circular. So the circular, as far as circular is concerned, simply linked circular also possible and doubly linked circular also possible. This is the basic idea about linked list and linked list implementation. And for understanding purpose, the same thing, linked list, okay, this is the model, doubly linked, this is the model, okay. So see here, okay, the singly linked, okay, only one address pointer is there, whereas here, okay, that is two, one is called next, other one is called previous. So previous, okay, for that is reverse purpose, this also holds the address and okay, so this is the model syntax for doubly linked list. And the other one is circular, okay, that is in this circular, see, we can see circular, okay, that is simply linked, and that last node is connected to what is called the first node. So this is the circular, simply linked circular, okay, circular simply linked list. And here, okay, circular is bidirectional, isn't it? Doubly linked, so that is this side also, okay, can traversal. See here, this side also can traversal, and what is called reverse side also we can traversal. So that's the reason why, okay, there is a circular linked list, okay, for complete circle what is possible, so without a null pointer. So sometimes it is also useful for example, continuous cycling, okay, for this purpose we can use. For example, any continuous task, for example, scheduling concept, we can implement with a circular linked list. This is the basic concept. So after that, as far as the performance are concerned, it's a very much important. So here, the time complexity of singly linked list I am focusing. As far as time complexity is concerned, for insertion and the deletion, okay, that is order of 1. That means irrespective of the size of the linked list, maybe that is 100 elements or that is 1000 elements or the 1C elements, okay, for insertion and deletion, okay, order of what is called the complexity time is 1. That means the same accessing time, okay. And others, for example, insertion and the end means from head, okay, wanted to walk through all nodes to reach end. Similarly, okay, insertion the position, I wanted to understand which position. For example, 100 nodes, I wanted to insert after 50th node, then okay, I wanted to walk from first to 50, okay. So that is the reason why for this and all order of time complexity is order of n. So this is a very important one, okay. This will be useful for implementing what is called a model with without compromising speed, that is a quality. So time complexity also wanted to analyze by designing algorithms and all. So next one is, okay, I am focusing, till now we focused linked list implementations and its features and characteristics. Now I would like to demonstrate simply linked list. As you know, simply linked list is the fundamental data structure, has what is called the next pointer, so that is a link is there. First is the head, first node is always considered as a head, and the last node address is a null. So like this, okay, we know already discussed. So that is the basic concept of simply linked list. So if I wanted to create a node, okay, this is the what is called the syntax code for code in C. For example, okay, in this structure, I created a node. Okay, node is the structure type. This structure type consists of data. So data I can store. In A I can store, B I can store. So that is a data. And after that, okay, that is a pointer variable I am using a next. So in this next is used to store the address of B according to this example. So this is used to create a node. Then after that, so after creation, okay, so this is very much important for okay memory allocations and all. So this what is called this code defines the function that it takes an integer data, that is called take the data, okay, integer data as an input and returns the pointer to node, return the pointer to node. So this okay code tells that is a new node. The new node has the data. Data is the integer type and it returns a pointer to this node. And similarly, that is sufficient memory to be allocated, okay, for storing the data. For this purpose, okay, that is address, that is called malloc we use. Okay, so that is a memory allocation model, malloc, you know very well. okay, use, okay, for what is called storing, that is node content and all. So this is a very important one for creating a new node. And we focus, okay, various operations of simply linked list. So the first operations we consider as the insert. So as far as insert is concerned, okay, first we are inserting, so that is at the head, okay, so that is adding a new node before the current head is making it a new head. So this is a very important one. So insertion operation, what is the process? Let us consider, for example, initially A is the head and B is another node, C is another node, D is another node, and according to this diagram, D is the last node. Now I wanted to insert at the beginning, and okay, so that to be head. So initially A is the head and followed by B is the first node, C is the second node, and D is the third node. So now I wanted to insert a new node, okay, at the first, at the beginning. That is a very important, at the beginning, so that whenever I am adding a first node, that node should be a head. So for example, according to this diagram, I am inserting a node E at the first. So see here, head is removed. That means A initially declared as a head, that is removed, and now, okay, head is assigned to E, okay, and E is linked to A, so that E becomes a head, and A is the first node, B is the second node, and C is the third node, and so on and so forth. So this is the process to insert a node at the beginning and insertion as the head also. What is the process? Create a new node with a given value. So E is created with a given value. Then move the head to point to the new node. Okay, that is I moved that the head to the new point node. Then return the new head of the linked list. Okay, linked list I joined. Okay, connected. Then this is the process for inserting a node. Clear? So as the first node I am inserting, the time complexity is, okay, that is order of 1. And the next one is, okay, for example, this is a code model, is a code for creating, inserting a node at the beginning. For example, insert at the first is a one function we created, okay, and as you know, okay, this what is called node can be created with the data as well as a head. So for that purpose, I structured created. So this is the function, and the function value I have given. So insert at the first, this function I am calling, and it is declared as the head, and after that the function value, that is the data value, is assigned as a tag. This is for understanding purpose. Whenever if you wanted to create a function to insert the node at the beginning, we can create the code like this. And other one is insert at the end. So that is called insertion at the tail. Okay. So insertion at the end means entire traversal. Okay. So that is starting from first node. That means head node. See the diagram. Okay. Starting from head node A, wanted to walk to B, then C, then D, and wanted to understand which is the last node. We can understand. So in this next, if there is a null, then that node is last node. We can understand. After that, I wanted to insert a new node. According to this diagram, I added E node. Clear? So for this purpose, for inserting at the end, I wanted to travel from the first node to last node, and once reached the last node, then new node I wanted to create. That is the first process. Create a new node with a given value. For example, one code I am showing. For example, insert at the end, the one function I created, and it is a node, okay, the pointer to pointer, isn't it? Which data? So see here, create a node with a given value. Node is created and the value I can assign. According to this example, okay, node is created at the end and the value 20 is assigned. According to this example, whatever value you wanted, you can proceed. Then, and very important thing is, okay, so we wanted to check the list is empty or not. Purpose is, okay, if that is a node, new node, and the head is the node. Okay, this is the condition purpose. And as I told, okay, wanted to travels till reaching a last node and we can proceed. So this is the small concept for inserting node at the end. So in this slide, we discussed, okay, how to insert the node at the beginning and insert at the end. Clear? So this is an important one. And after that, and one more thing is this already actually for understanding purpose, I have given what is a large image. Now, okay, insert at a specific position. That is a very important one. So in this previous, okay, what I told insertion at the starting or insertion at the end and like that, okay, we demonstrated. Now in the simply linked list for insertions, any specific position. For example, this is the head and the B is the first element and the C is the second element and D is the third element according to this diagram. So what's our demand? Okay, after B, I wanted to insert E. So the idea is, okay, E to be the second position. The message is very important. E is the second position. This is the node and B is the first position. After the first position, E to be the second position, then C third position and D fourth position. And like this, I wanted to insert. That means specific is position. So for this purpose, okay, I wanted to understand which position. The first means I already demonstrated, okay, how to add the node in the first, okay, and okay, that is otherwise the last means that also I demonstrated, isn't it, in the previous slide. Now if it is the specific position is very important. New nodes next, okay, to the next node of the current position wanted identity. For example, new node, okay, for example, this is the node, okay, B. After B, I wanted to insert E. So like that, what's what I wanted to do, okay, in this process, okay, B to, okay, C next address to be removed and, okay, this here the next address, okay, to be the address of E. Clear? So that this address to be updated here and we are making what is called a link. Then B is connected to E. Then after that, okay, in this next address, C address to be loaded and then we are making link. So now, okay, very clear, okay, this link is removed and a new link is created so that when executing, okay, first head, then first node B, then E, then C, then D and so on and so forth. So that is the idea. For example, see here, okay, for insert at position, at a particular position, one function was created and after that, okay, node head is there, data there, int is a new position. The position is very important one. See the example. So head I wanted to add, okay, and what is called the value of this new node is 15 and the position is 2. As a position is 2, okay, so here, okay, in the positions I am adding. So this is the first position and this is the second position. This is the head and this is the tail. So first position. For example, if I am giving a 3 here, what will happen after C? Here new node will be added. Clear? So this is the linked list operations. One is insert at the first and the other one is insert at the end and the other one is insert at the particular positions. So like this, that the code also I am showing here. Insert at the first, this is the procedure. Insert at the end, this is the procedure. And the insert at the particular position, this is the procedure. Then, okay, for these functions, I show you that is a complete code for process, for executions. These are insert. And as far as delete operations are concerned, similarly, okay, deletion at the beginning, okay, or that is a deletion at that is end, okay, or that is a deletion at the particular position. As the same procedure we can follow, okay, what is removing, okay, then what is called the next node is declared as the head. Okay, if end means, okay, end is deleted, okay, if after removing, okay, this previous node, okay, address becomes null. So you know the process, okay, you can comfortably understand, okay, these operations and you can implement. Because in this insert operations, I demonstrated all the process. So the deletion at the beginning, okay, other one is a deletion at the end. Then after that, okay, so code also I have shown. Okay, for example, delete from first. Okay, delete from first. Okay, structure node which head. Okay, and that the head can be okay mentioned so that may be click deleted. Similarly, delete from end. Okay, similarly that node we can mention so that will be removed. Okay, inside operations under the codes under the I will demonstrate. And other one is deletion at a particular position. So similarly, this is a very important one. For example, according to this diagram, okay, which position, the first position element to be deleted. So the 6 is the first. This is a head and the first, second, third, and so on and so forth. So that is deleted for this. Okay, one function created, and this is a model. Okay, which the position, integer position. Here the position I have given 1, so that 6 is removed according to this diagram. If I am giving what is called 2, then okay, this 12 will be removed. If I am giving a 3, okay, 15 will be removed. So that please understand the positions, locations. So like this, okay, insertion is possible, deletion is possible, and this is the advantages of what is called a syncly linked list. So that sequence of data wherever in memory space is there, okay, I can use that space for storing my data. So syncly linked is the best model for process. Okay, and small code is I am also going to demonstrate. Clear? This is for node creations. Okay, that is node created. This node structure node. Okay, data and what is called the next pointer is there. Okay, so this is a pointer to another node. The another node means what? The pointer to another node means okay, next node address will store here. Okay, then functions also I am creating here. Okay, so this already created and already demonstrated also. This defines a function that makes integer data. So integer data as a input and returns to the pointer to the node structure node. Clear? So integer data taking and returns node. Then after that for storing data, memory allocation address pointer I created. Okay, and like this I am proceeding. And then if it is the last and becomes a line. So this is one node I created. Then after that, like I demonstrated, code for function to the insert a new element at the beginning, and that is a new element at the end, and like this. For example, beginning means okay, this is the code. Okay, so here what we are trying to implement, so is a pointer. Okay, this is the pointer to the head of the list. It allows the function to modify the original head pointer, that is update the actual starting of the list. For example, see here, initially one node was there, so that is served as a head. Okay, now okay, I am creating a new node. Okay, and the data is also assigned, and the new node I declared as the new head. Okay, and the link also created. So this is a very important one. And at the end of the syncly, then okay, that is I walk through to all. Okay, then after that in the last I am adding. Okay, so that is one here. Very important operations. Thing is wanted to check the list is empty or not. Then traverse to this last node. Then wanted to append the new node. So that is here. Okay, so this check this empty or not. Then after that traverse fully going to last. Then I am coming. So new element at the beginning and new element at the end doing. Then after that, okay, insert a particular position. So the particular position means okay, very important one. Initially, okay, as I already demonstrated, I created. Then after that, okay, insert the position is 0. Is I am verifying if the position is 0, reuse the insertion. That is already we created, no? So insert at a position that the same I can reuse. Otherwise, I will come down here, check for what is called the position, whether the position is available or not. Okay, for example, I am telling you one position, the position is not available in this link. For example, let us consider A, B, C. Okay, A is the header, B and C are the two nodes. Okay, that is only two positions. I wanted to insert in the fourth position. I am giving a value 4, so that's not possible. So that for verification purpose, the position out of range, the verification purpose, I am using this one. Then after that, I am inserting a node. Okay, so this is for this is the code for inserting a node in the specific position. Okay. Similarly, for a delete for that is the first, and deleting for the last, and what is called deleting at the particular positions, and like this. Then, okay, the linked list I am printing. Okay, that is a structure node head. Okay, from this start. Okay, that is through loop. Okay, that is all that is data in the first node, second node, third node, everything. Okay, to be printed, and finally, okay, to print as the null. So these are the functions. So according to this example, okay, that is structure node for creation I created, and okay, that is new node creations, okay, function created. Then after that function to insert a new element at the beginning created, at the end to add created, or any positions, okay, I have created any position I can add a element. Okay, for that I created. Similarly, okay, node can be deleted from the first or last or at any positions. Okay, we created. Then after that, so what are the contents in this simply linked list? I wanted to print the for this purpose. Okay, that is code is created. This is one example. Like this, tens of different codes you can generate. First, understand the basic concept, and then you can develop a code. Okay, to print the linked list content, okay, code I created. Then after that, this is the main. So the main function, okay, so already told you, okay, that is a head. Okay, initially that is a node started. Okay, insert at first. Okay, for example, I wanted to insert, clear. So that is head, and what is the values I have given. After that, after inserting second data also I can insert. For example, 10 is inserted. So 10 is, okay, first inserted, and declared 10 is the head also. According to the code, you know very well. And the second I wanted to insert another data, okay, that is a 20. So the same function I am using, insert at the end. Clear. Insert the end means, okay, that is the first is what is called head, then after that second. So as far as, okay, this is added as the end, the second one is considered as the end, so that becomes a null. Then further, if you wanted to add, okay, one more data I wanted to add in the third one, the same function I am using, okay, insert at the end. Okay, so that is 10 is head, 20 is now, okay, last data. Then it is a null has, okay, the null is replaced, and 5 is inserted, and 5, okay, next pointer is becomes null. Okay, now, okay, 5 is the last element, and further you can add, okay, one more data. You can use the same function, insert at the end, okay, 30, okay, then 30 also inserted. The process you know very well, okay, that following the process. Okay, then after that, just for understanding purpose, I want to insert a node. Okay, the node is 15 and the position is 2. I already told you, very important. So according to this example, this is the head, this is the first position, and this is the second position, this is the third position. So see the requirement, 15 node. Okay, that 15th node, or that is node number is 15, value is 15, that should be inserted, okay, in the position 2. Which is position 2? Okay, so this head, this 20 is the first, and 15 is the second. So here, okay, so after 20, okay, before 15, I wanted to insert. That is a message. So for that purpose, I am calling a function insert at the position, and the head, okay, the value is 15 and the position is 2. After execution, that process, that what is called the function will be executed. Then, okay, after that is a proper execution. Okay, after 20th, okay, 5 is linked, that the node 5 is linked, isn't it? Sorry, here, isn't it? So after 20th, okay, node 15 is linked. Okay, so and it is proceed. Clear. So that, okay, first node, okay, head, okay, head retaining, 20 retaining. Here, okay, before 5 I told 15 wanted add, 15 is added. then after that 5 is coming, then okay 30 and so on and so forth. So it is successfully okay inserted a node okay based on our required position. Similarly for deletion purpose, first I can delete, for example, see here delete from first, okay, so that is first initially 10 is the head, okay, now 10 is removed and 20 I made as the head, okay, now okay 20 is the head, then 15 is the node and so on and so forth. Similarly last ones also I can delete from end, okay, with this function, okay, last node also I deleted, 30 is deleted here, isn't it? Then after that I wanted add, okay, I wanted to delete a particular node. For example, see here 20, 15, 5 is there, okay, I wanted to delete, okay, delete at a position first node, which is the first, okay, 15th. So 15th also removed after execution 20 and 5. So 20 is the head, okay, 5 is the last node and like this. So this is the code and this is the output, and I shown that is code also. So my dear learners, okay, in this video we understood what is a linked list and what are the purposes of linked list and how to insert elements in the initial position and last position as well as at a particular position like this and that. So as a recap, we discussed types of linked list like simply, doubly and circular, and two popular operations, okay, insert and delete operations we demonstrated, and through the code we understood the basic concepts and implementation ideas of simply linked list. So these are the applications. Simply linked list can be used to design, okay, that is a stack, queue and scheduling purposes. And if the data is, the arithmetic data is very larger one, we wanted to slice and small execution is required. For this purpose, we can use simply linked list. And for cache memory, because what are the recent data to be executed, that should be moved from main memory to cache memory, and from cache memory it will go to register for execution. For this purpose we can use simply linked list, generally for memory management. Tens of applications are there. Popular applications of simply linked list are stack, queue, scheduling, and for large computing purpose and memory management. So with this I would like to conclude this video. My dear learners, please watch these videos again and again to understand the concept clearly, and you can implement your own code to demonstrate simply linked list. Thank you very much for watching these videos. Thank you.